Hello guys, welcome back to the channel. Today's video is about the demo of the FHIR app built by us, OMAI, and I'm also going to try and cover the important points of FHIR and the basics of FHIR. So we are going to start with basics and we're going to talk about everything. So, you know, at the base, what is FHIR, why FHIR, and then what are the extensions in the FHIR, what are profiles, what are different implementation guides, uh, and what is smart on FHIR, which is very important. We are also going to cover FHIR types of FHIR apps. So yeah, there are various types when it comes to launching the app. So we are also going to talk about that a little bit. So let's get started. So basically, let's start with what is FHIR, Fast Healthcare Interoperability Resource. Now, okay. So basically, uh, in healthcare, when you go to a doctor or any hospital, all of your information is stored in the electronic health record system. So this is nothing but a software, okay? And when you go to doctor, all your information like your personal demographics and you know, your contact information and everything is stored, so which is called patients. And when you visit a doctor, uh, what so that visit is itself called as an encounter, which has some information. And then on that encounter, the doctor will ask you about your problems, and maybe will check your vitals. So yeah, so vitals and problems, which are nothing but what are the issues that you're facing. uh, they will document that on an encounter. So these are diagnosis encounters, you know and maybe he'll order a lab test or something, so orders. And then whatever results come out of those lab tests, those are stored in section called as observations. So basically your information is in the EHR, okay? And then you know all this information is used and to send a claim, and this information goes to the payer system. So even payer has your data. And sometimes before doing any procedure, so procedure is again another section, okay? So before doing any procedure, maybe if they want to do some surgery or something and that requires a prior authorization, then doctor, what he does is he sends a prior authorization, okay, which means that, hey, I want to do this procedure on this patient. uh, and payer says okay, fine, or whatever, denies it. So that's basically a prior authorization. That is basically an authorization that you need to provide any service before you perform it, okay? So just giving an example, so claims, and then once the claim is adjudicated, the payer will send back an EOB, which is called explanation of benefits, or even remittance, okay, different terminologies but same meaning. In EDI world, it will be called as X12835 format. Okay. So, okay. So basically, this is just a general flow. I just want to tell you that, EHR has some data that belongs to patient. Payer has some data that belongs to some patient. Now, uh, you know, now this is one EHR, another EHR, and suppose if the patient, this doctor, Dr. B, If the same patient visits here, the records are absolutely blank. So here what we require is interoperability. So we require a way that this EHR can share data with this EHR and vice versa. Okay? Or if this EHR wants, they can get data from the payer. Okay? Or if this patient A changes the payer, and if this payer wants, they can get patient A's data from this payer. So what this exchange of data is called interoperability. Guys, don't mind my handwriting. I'm really bad at it. I'm a health tech professional, but yeah, this handwriting is like a doctor's handwriting. So please excuse me for that and try to be with me. Okay, so this is called interoperability. And so to exchange data, okay, there has to be a certain standard, right? So basically, if I want to exchange patients' data, all these parties, this EHR, this EHR, or any EHR in the world, or this payer, or any payer, they have to agree to a certain standard so that the data can easily be exchanged. Otherwise, if EHR A has different standard and this EHR B has different standard, then it's going to be a one hell of a mess to exchange data. So we need standards, and what that standard means is that it is let's decide some format, okay, which everybody agrees to, okay, and we are going to stick to that format when we are exchanging data. So if I want to exchange patient's data, or if I want to exchange that patient's encounters data or his vitals data, you know, let's have a standard format. And that format is nothing but it is one of the part of FHIR. So one is the format. Okay. Now in you know in past there were formats. It's not that we didn't have formats. Okay, we have standard formats. We had HL7 version 1, we had HL7 version 2. Okay, even these are the formats. We have X12, and this is mainly used for claims, remittances, e eligibility. So we already have formats. Then why FHIR? Okay, so basically FHIR is a modern way of exchanging the data. Okay, so basically, what FHIR does is now they make use of RESTful APIs. Okay, so suppose this is Epic, this is Cerner. Okay, just giving an example. Now, what happens is now if you want to, and this is a FHIR app, suppose. Now, if you want to get data, any patient's data from Epic or Cerner, okay, what you're going to do is, okay, you're just going to make the use of standard APIs that are there. So, there will be a base URL and then the endpoint name, okay, which can be patient or observations, vitals, etc. Okay, so these are going to be endpoints, and this is going to be there's going to be a base URL. So maybe Epic's FHIR server has epic.fhir.com/whatever. or okay, and these are known as resources: patients, observation, vitals. So what an app can do now is, okay, there's an entire process, but I'm just going to try to simplify it. Okay, I'm going to oversimplify it. So now if this app wants to get data from Epic or Cerner, so any patient who is, their provider uses Epic EHR or Cerner EHR, what this FHIR app is going to do is just call the API, okay, their API, and get the data, parse it in their system or load it in their database. Okay. Yeah, and the same thing with Cerner. So only the base URL will change, but everything else remains the same. The protocol remains the same. The name of the endpoints will be the same. The query parameters will be the same. So patient and maybe ID equals 123. So this is a query parameter. So basically, FHIR came up with entire standard, okay, all the standard APIs, their names, only the base URL will be different, okay. uh, but there is an authorization endpoint, there is endpoint to get data for each and every resource. So when, as I said, a resource means a section of data. So basically patient is one resource, observation is one resource, encounter is one resource, vitals is one resource, lab observations is one resource, orders is one resource, and so on. Okay, so that is what FHIR does. Okay, and I'm oversimplifying it. We'll go into details, we'll look at each and every detail of how it does it. Okay, but for now, just keep in mind that that's how it is. Now, before we actually see how a FHIR resource looks, okay, let me just show you uh, the older formats. Okay, let me ask it. Uh, Show me uh example of ORU 001, which is lab observation, HL7 V2 message. Okay. Now, if you see, uh, HL7 is just a flat file. It is just a delimited file. Okay, delimited format, which means that uh, each and every data point is separated by something, and that something in this case is pipe. Okay, this first element is called a segment. So MSH is nothing but message header, PID is nothing but patient identification, OBR is observation results, OBX is again observation for if it's a blood test. So each and every element in that, like hemoglobin, hemocreatine, comes under OBX segment. So yeah, I'm not going to go in details of this because there's not a HL7 video, but yeah, just so that you understand. So this was the format in which data used to be exchanged. Simple flat file delimited. Now, there was no RESTful APIs on top of it, or no standards. Uh, I can have I can exchange this data with other entities, but not necessary that, my endpoint will be my base, whatever base URL plus, and uh, a standard name for this endpoint, which in our case is observations. Okay, it's a standard name, no matter where you go, what FHIR server you're dealing with, but the name of that resource will be the same. Okay, so yeah, this is just as I said, it's just a dead flat format. There's no standard on top of it. So this is how an HL7 message looks. And now, if you see a claim message, so let's ask ChatGPT for X12 837 professional um, example. Okay. 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 So again, X12 is also a delimited format. So in this case, if you see, each and every data point was separated by pipe, but here it is separated by asterisks. But again, so it's a standard format like uh, NM109 will always contain the NPI. Okay. Uh, yeah, NM1 with identifier 85, and this third element will always contain the billing provider name. Okay, N3 will always contain the first line of address. Okay, and so on. So it's a standard format. But again, here, again, to exchange data in this format, a lot of transactions right now, do happen in X12, and as far as my experience goes, till a very long time, I see this not getting replaced with FHIR, because yeah, uh, this there since long and it's working pretty well. But FHIR is mostly exchanging patients' clinical data. Don't quote me on that. I'm simplifying it, but yes, that's it. And yeah, so just wanted to show you how HL7 file format looks and how an X12 file format looks. Okay, now going back to FHIR. So, okay, first, before we jump into the demo of this application, let me show you how how FHIR format looks. Okay, now we have already seen how HL7 and X12 of X12 files look. Now, if you go here, uh, resources and JSON. So this is a patient resource example. Okay, and so this contains the patient resource. Okay, get used to this terminologies, guys. So patient resource, observation resource, condition resource. Okay, bundle resource. We'll see what a bundle resource is. Okay, uh, but let's first see what a patient resource looks like. Okay, so let me just open this in VS Code. I have bundled open, so let me get rid of this and open a patient resource. So you see it's a JSON format. Okay, and first key is resource type, which shows that okay, this is a patient resource. ID, okay, it's a unique identifier, FHIR identifier for this patient, and this is dummy example 123. Okay, and there's a metadata, what is the version of the record and the last updated. Okay, and if you go down, then okay, there are identifiers. So this coding is an array, and the system shows what is the identifier code system. So in this case, it's a medical record number. What's the value? It's MRN 12345, which is like it can be anything here, which is a medical record number for that patient in that EHR. So anything can be here. So basically, if you see, it's a well structured JSON format, and I think most of the request response that happens over the HTTP protocol right now happens in the through JSON format. So yeah, it's pretty easy to uh, you know interpret, parse, and generate. Okay, so a lot of libraries available to do that. So yeah, so in short, I just wanted to show you how a FHIR resource looks, and don't get bothered by the squiggly braces and everything. It is just a simple standard way which everybody follows. you know Resource type will have patient or observation or vital. So ID will always have the unique identifier of that resource, and so on. So each and every format, each and every resource is has different keys here, key and values. So this is the patient. Let's look into uh, the observation resource. So let me copy this. The only reason I'm copying this and showing it to you on Visual Studio Code is because yeah, the format is prettier here, and this is not very much readable. So I tried my best, but I couldn't get around the CSS and make it more readable. So anyways, so This is a resource type of observation. Now you may have guessed already because in previous example we saw that resource type was patient. Okay, now if you see the coding system, this observation is of vital signs. Okay, which means that your blood pressure, your height, weight, your SpO2, temperature, all that comes into vitals. And yeah, if you see coding, it's uh, basically this code that follows this system shows what code is this. Okay, here it says that it's a loin code. Loin is basically a standard coding system used for all kind of observations, so may it be laboratory observation or assessment observations or any vital observations. There will be a standard loin code. So even if you search this loin code on the internet, it will show that it is for blood pressure, and for systolic and diastolic there will be different loin codes. So yeah, so basically this resource type observation is just the JSON structure, to provide the information about a patient's observation. Okay, and yeah, all this data is stored in EHR, and uh, when it has to be exchanged, then this is the format how this data is exchanged. Okay, all right. So I hope that is clear. Uh, what FHIR format is and how it uses RESTful APIs to exchange data. Okay. Now, moving ahead, these are very basic FHIR resources. Okay, and you can actually go to FHIR's website, which is hl7.org. Okay, and /FHIR, and here in the resources section, you can see all the resources. Okay, so N means normalized, which means that this resource is matured enough, uh, and is almost final. Okay, so if you look at this patient resource, okay, uh, now name is obviously the name of the field. Okay, uh, and then the most important thing I want to show you is this card, which means cardinality. Okay, and wherever it says 0 to anything, so it means that uh, it is optional. So the value can be nothing, or that it is okay even if there is no value present, and there can be multiple values present. Okay, so 0 to star means that cardinality. 0 to 1 means that it is optional and it can contain one value. Okay, and then this is a data type, FHIR data type. So yeah, so this is what is important. So if you see, a basic FHIR resource is just a very basic definition of what a patient resource should have, because a lot of fields here are optional. Even like if you see, name is optional, telephone is optional, and this doesn't really, if we use if you use this standard, the basic standard, to exchange the data, it's going to be almost impractical, because in real scenarios there are a lot of fields that you know should be mandatory or are mandatory when exchanging the data. Like for here, in case name, identifier, they should be mandatory, right? But this basic resource doesn't say that they are mandatory, and hence this is not something that is used in real world. But this is just taken as a foundation. Okay, and there are profiles created on top of it. So let's see what are profiles. Okay, so I wanted to explain you what is profiles, what are profiles, and that's the reason I had to show you how a basic FHIR resource looks, and how most of the fields here are optional, if you see, and this is not going to work in real world use cases. Okay, uh, okay, just on a side note, it's different formats: UML, XML, how it looks in JSON format. Okay, what is the difference between the R3 and R4 version, everything. So yeah, just so that you know. Okay, now let's go through what are profiles. Okay, so if I click on profiles here, so profiles is nothing but basically just look at this example here. Okay, now the US core patient profile and the difference between the base patient resource. Okay, so profiles is nothing but it defines a schema. uh, it defines what fields should be required and not required, and all the data type, and uh, there is something called as extensions, which we'll talk about later. But right now let's focus on profiles. Okay, so profile is basically just defining the schema. So if you see in base patient resource, identifier is optional, name is optional, gender is optional, birth date is optional, and there is no race and ethnicity fields. Okay, so what profile does is it defines a specific schema that a, a resource has to you know be structured into. And so basically it defines the schema. Like if you see the database schema, how in the database we define that patient's first name, last name, patient ID as a primary key is mandatory, and it won't accept uh, a blank value there, or how email should be in a specific format, how a phone number should be in 10 digits. So that's how you define a schema, right? So this profile is nothing but it defines the schema of the resource, how the information has to be shared, and what information needs to be there in that resource to according to this profile. Now what are the extensions? So extensions is nothing but uh, a base FHIR resource. uh, as I told you that it's a foundation, defined by FHIR, and you can build on top of that. So let me give you an example. Here we have a good example. So race extension. Okay. So because base resource doesn't have a race, so what I can do is I can add an extra field to my FHIR profile. Okay, and that is nothing but an extension. So there is an extension for race, there is an extension for ethnicity. So here if you see US core race. Okay, so see how they've added this extra field here. Okay, as core ethnicity, US core ethnicity, and US core race. So these are nothing but what I do is, so a standard FHIR format, okay, a FHIR resource, if it doesn't give me ability to exchange some information, and I want that I think that information is mandatory, then I can create an extension out of it, and those extensions and cardinalities and whether it's required or not together makes a profile. Okay, so here if you see there is a US core patient profile. Okay, so hope we are clear till here. What we have learned till now is what is FHIR, okay, format plus the usage of modern technology, which is RESTful APIs, how it creates a standard and a platform to exchange data between no matter what EHR or what payer. Okay, we have seen that till now. We have seen the basic FHIR resources, how a FHIR resource looks. We have also seen HL7 and X12 messages, how they look, and we have seen what is the difference between them and why FHIR now. So, and we have also seen how a basic FHIR resource, may it be patient, vitals, observation, any resource, how it can be extended and how there can be, custom fields added to it, which are known as extensions, and how those extensions and uh, how my schema definition, okay, creates a new profile for me, which is built on top of the basic FHIR profile. Okay, all right, so hope we are clear till here. Now uh let's look at, all right, now after the profiles and extensions, which I hope that you guys are clear about, let's see what are implementation guides. So as the word suggests, implementation guides is basically uh, specifications which tells you how to implement uh, implement something. Okay, and in this case, maybe a resource. Okay, so first of all, there are different implementation guides. Okay, and there is a reason for that, because there are uh, different requirements when you exchange data between different entities. Okay, so if you see here now, there is a implementation guide called as US core. Okay, okay, so basically when you want to exchange clinical data. What I mean by clinical data is, again, this is the same thing, your electronic health records, the data that is stored in EHR, which is related to your health, that is called clinical data, like, again, vitals, observation, orders, plan of care, diagnosis, procedures, encounters, and all that. So that is clinical data. Okay. There's another implementation guide for Smart on Fire, and we will see what Smart on Fire is in detail, okay, and step by step in detail how it works. Okay, so but yeah, that is an implementation guide to basically launch a Fire app, and how the authorization should work between the client, which is your Fire app, and the Fire server, okay, from where you're going to get the data. So I'm just giving one use case here, which is of Fire app and the Fire server, which is at the EHR's end. And Smart on Fire basically defines, it is based on the OAuth 2. Okay, and it defines how the authorization should take place between the client and the Fire server. Okay, so that is what it defines. So that is the implementation guide for app launch and authorization. Karen Blue Button is payer to consumer. So basically, as I told you before, that your claims data, your EOB, all that data is stored on the payer system. Okay, so when there is the exchange, like suppose you're using a Fire app to get the data from your payer. Okay, then Karen Blue Button implementation guide defines how, you know like all the fields in the explanation of benefit or in the claims, and basically it defines the entire schema for claims and EOB. So whatever data is exchanged between the payer and the consumer. Okay. Then there comes a DaVinci. Okay, and it has several different formats, but we'll talk about PDEX. It's important. It's payer data exchange. Okay, so this is mostly from payer to provider and payer to payer. Okay, PASS is for prior authorization. Okay, so this is, as I told you, uh, any provider can send a prior authorization via an API call, uh, get the status of that prior authorization via an API call. So, before, where it used to take days for prior authorization, and, you know, it was so inconvenient because patient had to wait for the service that, for the procedure that he's supposed to go through. They have to wait for days for that. But now it is quick. It is just make an API call, submit your prior authorization, and if it is approved, get the prior authorization number from the payer. So yeah, so basically, for prior authorization exchange, so what all information has to be in prior authorization, uh, you know PASS is the implementation guide for that. Okay, DaVinci, PASS, and PDEX is peer to provider. So for provider API, QI core is for quality improvement and measures data. So when that data is exchanged, it should follow the QI core implementation guide. Okay. So guys, if you have understood it till here, believe me, you're almost there. Okay, this is very important. So I've taken you right from the foundation, how a basic fire resource looks without extensions and without profiles, and then how extensions are applied on that, and how the definition of the schema makes a separate profile, and then all these implementation guides. Okay, so remember, this implementation guide defines how, what data should be exchanged between, if you're exchanging clinical data, or if you are launching an app, fire app, and want to do the authorization, then how it should be done. Karen blue button, how uh, you know when a data flows from payer to consumer, basically claims data, EOB data, then uh, you know what all fields are necessary, and basically the schema of that. So yeah, remember this. And not only this, but let's go through an example. So payer to consumer data, Karen blue button. So let me so here I have links to all the implementation guides. I may soon host this web app somewhere so that you guys can, try your hands on it. Uh, okay, so Karen blue button. If I click here, it takes me to the page for Karen BB implementation guide. Okay, now fire artifacts, and if I go to profiles, okay, now see, each implementation guide has different profiles for the same resource. Okay, so if you see Karen BB, though the resource is explanation of benefit, but it has separate profiles for it. So basically, because there the fields in an explanation of benefit for an institutional claim, for a dental claim, for a professional claim, okay, or for a pharmacy claim, are separate, and that's the reason these profiles are created, guys. So actually, even if you go back to X12, you will see that X12 has 837 is not just one format in which the claim is sent. 837 has a separate sub formats, like 837p is for professional, 837i is for institutional, 837d is for dental. In same way, because the requirement of sending dental claims, the fields or the data fields or the information that should go in a dental claim or that should go in an institutional claim, just to give you an example, that in a dental claim I have to show what teeth, what number and everything. Institutional claim, there might be surgical procedures and surgical provider, operating physician, and the revenue codes that go on the institutional claims, whereas on the professional claims those are not the required field. So that's why it has separate profiles. So profile means separate requirement, okay, separate fields, optional, required or no, cardinality, extensions applied to it makes a profile. So I hope that is clear, guys. This is a fire app that we have created, and this is to demonstrate the different types of launch that a fire app can have. So basically, if you see here, there are three types of launches. Okay, one is actually not used in the real world, which is launched without without an authorization. So which means that anybody can just go call the endpoint and get the data, which is not a real world scenario. But these two are the real world scenarios, which is one is where uh, it's a standalone app. So you just the patient or the provider, whoever is the user of the app, just goes to the app and uh, uh, and uh, basically then the authorization process starts from there. Okay, and one is the EHR simulator. So in this case, what happens is the app itself is in your is in the EHR. Okay, so like you open a patient chart, and then if you want to go to a specific, suppose that's a let's consider that if it's a patient with some heart condition and somebody has created a FHIR app for cardiology, uh, get reading all the patient's information and doing some predictive modeling on that. So in that case, it is the EHR simulator. Okay. Now, as we do not have a real EHR here, but Smart IT has given us a platform to simulate that, launching the FHIR app from EHR. So let's see how it works. Okay, so when I click on EHR simulator, if you see, I am being redirected to launch.smarthealthit.org. Okay, now here what I need to do is I just need to put my app's launch URL. Okay, in my case, it is the app is hosted on it's on my local host, so it's localhost port 3000 and launch. So once I click on launch, okay, so understand, now I, as a doctor, okay, just imagine that this screen is my EHR screen, okay, and this launch button is just my application icon. Okay, and here, instead of all the smart launcher and everything, I have patient's information. The patient's chart is opened in front of me, so I have I'm looking at his information, and then I say, hey, cardiology FHIR app, okay, open, and then it opens. Okay, now in this case, it is going to take me to the authorization server, but in real world, it doesn't happen like that. The authorization happens behind the scene. I don't know why this, it may be because of my network. Let me try again. Okay, it's happening. Yeah, I am having some network issues. If you see, I almost do not have network. Okay. All right. So now here it is taking me to the EHR's login page. Okay. So this is like login with Google, login with Facebook. You must have seen it, right? Whenever, so that is called OAuth. Okay. And OAuth, we do it a lot. We use it in our real life a lot. A lot of applications and websites do have OAuth authorization feature where we authenticate ourselves with our Google login or Facebook or Instagram. So in similar way, here practitioner has to log in to their EHR screen. Okay, and I will tell you in detail what happens later, but let's go through the demo right now. Okay, so I log in as a practitioner, and now it shows me all the patients that I have access to. All right, so on this EHR page, let me select a patient. So basically, this is not actually what's going to happen, but I'm doing it manually. I'm selecting the patient manually. But remember, in the EHR, I've already selected the patient. So the context of the patient is automatically going to be passed. Okay, so let me select this patient, David Alcantar. Okay, so the authorization has been completed. Exchanging authorization code for access token. Okay, loading the dashboard. Now I have got information for David Alcantar. Okay, I've got his encounters. Okay, I've got his observations, got his medications, got his allergies. Okay, so this is how I get all the information about that patient in my FHIR app. Okay, now I'm not in EHR anymore. Okay, I just launched the app from EHR. The EHR passed the patient context, which means the patient ID or their encounter or whatever, and then I was authorized by the EHR server. It gave me the access token to now access all the other resources. Okay, so that is how it works inside the EHR. Okay, now let's go back and let's see how a standalone launch with OAuth works. Okay, and at this case I've configured the Epic's FHIR server. Okay, there its authorization server. So as soon as I click on this, see what happens. So it takes me to fire.epic.com interconnect FHIR auth. Okay, API FHIR are for base URL. Now it's redirecting me to the authorization server. Okay, now you see this is a real epic hyperspace page, okay, where I'm going to log in. And if you see this fire 2, this username and password, it's for a provider. I've got it from their fire's developer portal. Okay, so they have all the username and passwords mentioned there. So once I log in, now what's happening is this is a standalone launch. Okay, so first when I launch it, it knows that it has which authorization server it has to redirect me to. Okay, and it redirects me to that authorization server. Now I log in here. Now see what happens. Okay, it is okay. I'm still on the Epic page. Okay, it says confirm external access. Are you sure you want to grant OMAI Fire app access to data on your behalf? I say grant access. Okay, now see what happens. So now I have got this patient, Sarah Jane Johnson. Okay, because that was the that is the patient's context that we passed after getting the authorization token. We use that authorization token to get the patient resources. Okay, now annual physical examination, see observations, blood pressure, allergies. She's allergic to penicillin. Okay, if you see medications, we have she's taking all these medications. Okay, now what we can do is, now this is a feature that I have built in this Fire app. Okay, where now you have all the patient's information. Now you want to do some clinical analysis on that patient's entire information. Okay, so I just hit clinical analysis. I do start clinical analysis. This may take some time because so we have a model hosted on a runpod. Okay, I'm using uh so basically I was training a model. You can see it in my previous video. I've trained a llama model. So uh I'm using that model to do the clinical analysis. Okay, now the clinical analysis is done, and what it says is, let's see, executive summary. Sarah Jane Johnson is a 40-year-old female with well-managed type 2 diabetes mellitus, hypertension, and high cholesterol. Her recent lab results indicate good control over her condition, and she is adherent to her current medication regime. Key findings: HbA1c is at 5.8%, indicating good glycemic control. Blood pressure is well controlled. Okay, active conditions: diabetes 2 mellitus. Okay, immediate medical attention required for any allergic reactions, especially to penicillin. Okay, so it is saying that nothing else, but only she's allergic to penicillin. Uh, so immediate attention is required there. What else? Okay, it says diet recommendation: high fiber foods such as fruits, vegetables, and whole grain foods to avoid sugary foods and beverages, processed food high in sodium, saturated fats. Okay, meal planning, lifestyle recommendation: exercise, sleep, stress management. Other recommendations: is there any health risk and any prevention? Moderate risk from cardiovascular disease, complications from diabetes, low risk. So basically, what this model does is it takes that patient's entire medical history. Okay, right from allergies to medications, everything that you see here. Okay, and it does its clinical analysis on that, and it returns all this clinical summary and everything. Okay, all right, now comes the important part. Now let's see how the authorization works. Okay, so I already have a documentation here which I have created. So let's go through the OAuth flow. Okay, how it works. So what happens is basically, okay, when user initiates a launch, okay, the app generates a random state parameter for security. state value is nothing but it is just basically to it's like a handshake. So basically when I send a you know I will generate this and I will store it in my in the session. Okay, this can be any random UUID. Okay, and I will send it with the authorization. Okay, now when the authorization server redirects it back to my app, it will return the state. Okay, which will prove that it is indeed the response from the same server that the request was meant for. Okay, so just for security purpose. Now generate PKCE challenge, again this is also for security. So basically what happens is uh, so that a hacker you know if he intercepts, so when you send a request to the authorization server, and authorization server is sending you is redirecting back to your app with the authorization code, because that authorization code is important. That is what you're going to use to get the token. Okay, and okay, so I'll explain you the entire flow, but remember this. So what verifier does is, verifier is any random string that my app generates. Okay, and it stores it. Okay, the verifier is not sent when to the authorization server. What's sent is the the challenge. Okay, what the code challenge. So code challenge, what it means is it takes this verifier, it encrypts it with SHA-256 algorithm and encodes it with base 64 URL. So it generates a encrypted string from the actual verifier. Okay, now what happens is when this is sent to the EHR's authorization server. Okay, if you see the code challenge is this code challenge method, it says it is this is an encryption of some random string with SHA-256 method. Okay, so now what that EHR's authorization server does is it stores that encrypted string with itself. Okay, so now the client has the original verifier. Okay, and the authorization server has the encrypted form of it. Okay, which is encrypted with SHA-256. Okay, and it's a one-way encryption. You cannot decrypt it back until you use some brute force methods. Okay, so how it helps is, okay, and the important thing is uh you go to the authorization server with your client ID. Okay, this is a client ID that when you register with that authorization server, like if I register with Epic, they assign a client ID to me. So this client ID is important in this authorization request. The redirect URL, so once you're authorized, what is your callback URL? So this will be your app's callback URL. Okay, the scope means the permission. So patient star dot read means all the resources for that patient and only read permission. Okay, and the open ID or the FHIR user. Okay, state we have spoken about, again it's a random UUID. Code challenge, again we have spoken about it, but I'll explain it to you in detail. I'll draw on whiteboard so that you can understand it better. Okay, and what happens now is user logs into EHR and grants the app permission to access their data. So once they log in, okay, then the authorization happens and the authorization server returns this auth code. Okay, remember this auth code. Now any hacker should not get this auth code, because then he can take this auth code and uh, uh, call the API to get the token. It's not that straightforward, guys, but I'm again oversimplifying it. But to avoid that, there is a verifier, because now if you see, okay, once I get the auth code, I exchange it for token. How do I exchange it? Now it's not just the auth code that I'm sending. Now I'm sending the original code verifier that was stored in my local session when I and I encrypted that with SHA 256, and now the FHIR server has the encrypted form and I have the original verifier. Now I get that auth code and I send the code verifier along with that auth code and the client ID and the redirect URI, okay, to get the access token. Okay, now I get the access token here, and then using this access token I can make any calls which are in my scope, in the scope defined here. So in this scope, I can make a call to any resource and I can read that resource. So using this access token now, I can get patients information, I can get their encounters, I can get anything that is there, you know, yeah, the resources that are there. So this is how smart on FHIR works. Okay. Now let me explain you the concept of PKC, which is proof key for code exchange. Okay, we are going little into detail, guys. It's important if you are implementing it. It's important for you to understand how it works. Okay, my app creates a verifier. Okay, verifier is nothing but any random string, any random value. Okay, A, B, C, D, E, F, 1, 2, 3, 4, whatever. Okay. But when calling the FHIR authorization server, auth server, I'm not sending this verifier. Remember, what I'm doing is I'm encrypting it with SHA 256, this verifier, original verifier, encoding it with base 64 URL. Okay. Now this creates some other encrypted value of this original value. Okay. Anything, suppose da 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 da. Okay. And I also, so this is called as code challenge. Okay, code challenge. And there is a code challenge method that I have to send to this authorization server, because I have to tell it that this encrypted string, how I have encrypted it. So I tell it I have used SHA 256 to encrypt it. Okay. Now, what does this FHIR server has? This FHIR server has my code challenge. So it will store the code challenge. Okay. And it knows that I've used the code challenge method as 256, SHA 256. Okay. Now, when I go to this authorization server, I log in with my username password. Okay. It is going to generate a auth code and redirect it back to my app. So basically, it will say after authorization is done, it will say omai.com. Okay. And it will give the auth code. Auth code equals whatever 1, 2, 3, 4, 5, 6. Okay. Now remember, guys, till now I haven't got an access token. This is just the first part. I've just got the auth token. Okay. Now when it is sending me this auth token, I'm just explaining this to you so that you understand security wise. Okay. So that nobody, if somebody sniffs it and if they get hold of my auth code, okay, they shouldn't be able to call the token API to get the token, because if they have the token, then again they may be able to. There are other bindings also, like the IP address and everything, which makes it practically impossible. But that's a part of you know uh, that's a part of our HTTP protocol. But this is an OAuth flow. Okay, so to avoid this, what we do is, now once you receive the auth code, okay, how the token request is made is that we will again call the from here we will call the token API. Okay, and what we are going to send is now auth code, scope, client ID, and most important now the original verifier. Okay, this original verifier, not the encrypted part, because encrypted is already here with them. So when I send the original verifier, okay, now what this token API does is it will now it has this FHIR server has your code challenge with it. Okay, so when you send this auth code, it is not only going to check the auth code, it is also going to get this verifier. It will encrypt it with SHA 256. Okay, and compare it with the one that it already has for you, and if that this comparison matches, only then it will return the access token. And now to think about, we can think anything that attacker can even sniff this verifier, you know when this request is going. But it's almost practically impossible, because even if they sniff this verifier, there's a TLS. They have to break that, decrypt it. Meanwhile, this verifier is already being used, and this verifier, very important security thing to remember is that it is only valid for one request. So once this verifier is used to get the token, it expires. Then this FHIR server won't recognize this verifier. Okay. Okay, and once you get the access token, now this app gets the access token. Now using this access token, it can access all the endpoints mentioned in the scope, and it can get patient's data, and then after that you can do anything with that. So guys, I hope this entire thing is clear, because this is key part to understand smart on FHIR. All right guys, so I hope this smart on FHIR authorization framework, that is clear. Okay, we have seen it in detail, very detailed as possible that I can go. Okay, uh all right guys, I will soon be hosting this page somewhere, and I will post it in my YouTube channel once it is posted somewhere, so that you guys can play around with this. Okay, one more thing that I want to cover is about the 21st Century Cures Act. So, this is a law which mandates the healthcare providers to give patients secure access to their health information, okay, without information blocking. And there is some important thing, because I wanted you to think, I spoke about, we did not touch a very important point, that as a patient or as a provider, if I download any FHIR app, okay, how does that FHIR app know? The smart on FHIR starts when my app knows which authorization server do I have to redirect to. Okay, but till then, how does my app know that it's a standalone app? It's not being launched from EHR. So how does my app know uh, the actual FHIR URL? So here is where what I wanted to discuss. So ONC FHIR endpoint directory. Okay, this is a centralized directory where, so basically, imagine what you're going to do is you are going to what FHIR app, standalone FHIR app is going to do is it's going to ask you something like, hey, who's your provider? And once you enter Mayo Clinic or St. Mary's Hospital, it's going to search this directory, this endpoint. Okay, and in this directory it will get all the information about that provider, including once you get the FHIR base URL. Okay, and the Then you can initiate the OAuth process, and then everything goes from there. But yeah, this is an important point to remember, that there is a ONC FHIR endpoint directory, okay, which is a centralized directory. Hope you enjoyed this video. And if you're doing, or if your organization is doing anything, uh, related to FHIR, I would love to collaborate and hear about what you're doing, exchange ideas, and hope you guys liked the video. Thank you for watching. And if you have any questions or any comments, please leave it in the comment section. If you want to collaborate, please put a comment in the comment section, and I can give you my email address, or yeah, we can have a small chat if you're doing anything related to FHIR. I want to exchange ideas. I want to have a small podcast. I'd be interested in doing that. All right, guys, thank you so much once again. Have a good day. Bye bye.